this is the graph of your transformer differential protection on the percentage thing. We have 40% here, and the other one is 80% slope. So if the fault is on this location, you should operate in this relay, and you should set your instantaneous protection at 800%. This is how we model our Aspen one-liner. This is the 500 kV bank, 525 kV bus, 230 kV. We have the 13.8 kV bus. We have the shunt reactor. And this one is the current limiting reactor. So as power systems protection engineer, we can model our transformer impedances from high to low, low to tertiary, high to tertiary. And the 525 kV transformer is Y grounded, delta on the tertiary. And you can use to model it as an auto transformer. So we get all the positive sequence impedance here. You see that the relays operate instantaneously, 0.0 seconds. The same here. On the low side of your 230 kV bank, which is the 230 kV side, you're using a mole phase distance protection to protect the 67% of the transformer, 120% right after the transformer. So you have your zone 1 here, you have your zone 2 here, and you can set this at like 20 cycles. The other one could be 60 to 90 cycles. Another shot of the faults. This is the overcurrent protection here. Magnetizing inrush current. The current transformers, you need to know the characteristic of the current transformers and the transformer phase shift also. When we energize the transformer, we will capture on the first energization, the second energization, and the third energization, we will capture all these inrushes. And these inrush sometimes are very troublesome because it increases your first current coming in, and you might trip on this inrush. So what we do is that we use the second and fourth harmonic as additional restraint on our inrush to protect the transformer from inadvertent sudden pressure relay. So your main tank has a sudden pressure relay. Your LTC chamber, when you do your load tab changing equipment, it has also a sudden pressure relay in it. So you can utilize it to protect your transformer the best way, because this is an alarm at the same time. In my past experiences for all the sudden pressure relay, the sudden pressure relay saves a lot of our transformers, you know. When you do your maintenance for a high voltage transformer, and if you want to turn off your transformer differential relay, it is a must to put this in service. You know, the sudden pressure relay must be cut in all the time. Aside from, if you turn off the transformer differential, turn on or enable your high side overcurrent, your time overcurrent, and the sudden pressure relay. Do not leave your transformer unprotected, especially without the transformer differential protection. Yes, the slow breakdown of your transformer insulation produces gases in the tank like methane or ethane, and the gases rises through your oil to gas accumulation chamber. It detects the incipient faults. Voltage equals the flux times the frequency times your K1. So the overvoltage protection is on your transmission line. You have a long lines, for example, and the end of the line becomes a little bit higher, so you need to have some 24 volts per hertz protection. So we set this volts per hertz protection at 110% for your alarm, or 120% for 23 seconds, 130% for 6 seconds. So this is a real-world experience wherein our shunt reactor banks on the 13.8 kV side caught on fire because of deterioration or old age already. So when you close your shunt reactor bank breaker, you are making a three-phase fault, to energize your shunt reactor banks. So let's see if our transmission protection operates, transformer protection operate properly. You can see here, if this is your phase Bravo, phase Charlie here, and your phase A over here, what happened to the shunt reactor bank on the delta tertiary? What kind of fault was present there? Is it an A phase fault, a B phase fault, or a C phase fault? Based on the waveform here. We can ask our students, to take a look at the drawing here. You have an A phase, B phase, and C phase currents. So what happened from this cycle to this cycle here? What phases picks up immediately? Can you speak louder? No more chocolates, okay? So what about here? What kind of phase fault come up? Is it a phase fault, a B phase fault, or a C phase fault? Who said A phase? Who said B phase? Who said C phase? Don't be ashamed. So this is your A phase current here, B phase current, and the C phase current. I can see blue, I can see red. So from 2.5 of a cycle to 5 cycle here, this is where my trip comes up, and I'm looking at my 50 instantaneous device goes high, and my 51 P device, your time of recurrent pickups, From 2.5 to 5 is like only 2.5 of a cycles. But your relay operated properly, picks up the 50 instantaneous device and trip the breaker. So I can see B phase and C phase here. So the fault is a line-to-line fault, B and C phase. Is it correct or not correct? More coffee, please, more coffee. Okay, let's see what we have.